Hello YouTubers, I just wanted to go over this project that I was working on today. I started this morning, so I haven't been working on it too long, but it's getting to a point where I can actually use it. We have a small issue with our beagle puppy. She's mostly house trained, but every now and then she decides that she wants to tinkle indoors, so what we decided to do is put up some kind of audible alarm system so that we can tell when she's going over to the problem area of the home, so that we can quickly go to her and take her outside. And we're hoping that will help us out a bit. So I just wanted to go over the current state of this project. I have a 9-volt battery. It's currently just taped on here, but I'll most likely put a Velcro strap to secure it. And I'll weatherproof this a little bit later as well. But what we've got here is a 3-volt Trinket from Adafruit, which is mostly Arduino compatible, a 38 kilohertz IR receiver, and a small Piezo buzzer. The system, when it's up and running, draws about 9 to 12 milliamps depending on what it's actively doing. LEDs obviously burn a little bit more juice. I do have the software programmed so that you can configure a sleep period. I currently have it set to 4 seconds, so after 4 seconds of not receiving a valid code, the microcontroller goes into a sleep, and this particular board will end up drawing only 3.7 milliamps in that state, which is a considerable power savings. The majority of that 3.7 milliamps is coming from the green power LED that's over here. I will probably cut the trace on that to further reduce the power consumption, because there's no way to turn it off. It's not attached to the microcontroller itself. It's just on the voltage regulator. So I'll go ahead and power this up and show you guys how this works. Alright, there's the heartbeat on the red LED, and it turned off after 4 seconds. So this device is now in a sleep mode. It's not using that much power, but if the puppy should happen to go anywhere near this, which is a virtual wall from iRobot, these are used for Roombas, I've taken a liberty of taping up the omnidirectional beacon on the top here, because this receiver is very sensitive. In fact, I just triggered it off the reflection from this wall. And I did it again because I moved my hand away from the beam emitter that's in the front here. So I'll have to find some way of dealing with that, because I do use these for my Roombas as well. But this particular one I've modified with the tape just to prevent this thing from going off 24/7. Now, this device has a programmable threshold, so if there's false positives from just ambient light, it will reject those. I currently have it set to require 3 valid codes from this device in a 2-second period of time in order for it to trigger the alarm. Actually, I think it's about a 1-second period. It has to receive 3 codes. So if I bring this over, you can see it wakes up, but it doesn't beep because I removed the source before it managed to trigger the threshold count. So every time this thing goes into sleep, it resets that threshold counter. So it is pretty responsive. It wakes up immediately and does its business. So yeah, it's just a matter of cutting the trace on that power LED like I mentioned, and hopefully I can get the power consumption down under 1 milliamp. I'm pretty sure it will be. So I'll post the source code for this project online. I'll put it up on my GitHub, as well as the schematic. It's really simple though. There's really not much going on here, but a project like this could be used in many ways. You can use other devices instead of a piezo buzzer. You could even use one of those shocking collars that are used with electric fences, and use this in conjunction with that if you wanted to hack one of those. That way you can set up indoor fences without having to tear up your carpet to lay the wiring down. And you can make your own beacons as well. You don't have to use one of the iRobot's virtual walls. In fact, I just recently managed to clone one of the iRobot virtual walls by using another Trinket, as well as make a Roomba IR controller out of it. I did that earlier today. So you could use one of these to actually build the virtual fence indoors with the IR beacons. So I hope to put this online, like I mentioned, and hopefully someone can make use of it. Alright, thanks for watching, guys.